Alright, today we're doing multivariable linear systems and row operations. And we are going to solve systems of linear equations using matrices, Gaussian elimination, and Gauss-Jordan elimination. We have multiple different vocabulary words: multivariable linear system, real echelon form, Gaussian elimination, augmented matrix, coefficient matrix, reduced real echelon form, and Gauss-Jordan elimination. Multivariable linear system is a system of linear equations in two or more variables. We have different operations that produce equivalent systems. So you only have three things that you can do. Only three? Yeah, only three. So our first one that we have is interchange any two equations. So let's say I have three different equations. What that allows me to do is that allows me to change those orders. So I switch the second and the third one. Next, you can multiply one of the equations by a non-zero real number. A non-zero real number. Now, that means that it can be a fraction. So it can be a fraction, can be a decimal, it can be positive, it can be negative. Just cannot be zero. And last but not least, we can add a multiple of one equation to another equation. Our first step is that we want to make sure the leading coefficient is 1 for our top equation. It is, so then we can move on to step 2. Since that was already a 1 right there, then that allowed us to go ahead and move right along with that second step, which essentially is like step 1. So we want to eliminate the x term in equation 2. So remember, we have our 3 steps that we can use. Step 1, we can interchange any two equations. That's not going to eliminate anything. Second one, we can multiply one of the equations by a non-zero real number. Still, not going to eliminate anything. The only way for you to eliminate something is we add a multiple of one equation to another equation. Alright, so I can multiply my equations. But first, it'll be good if we can number those equations. So our top equation is going to be equation 1, our second equation is going to be equation 2, and the last one's going to go ahead and be equation 3. So we have those named. Then the next thing that we're going to do is we're going to say what we can do to eliminate that. So if I do negative 3 times equation 1, and I add that to my second equation, equation 2, that will give me my new equation 2. So what happens is our top equation and our bottom equation is going to stay the same. Notice we multiplied equation 1 by negative 3 to give us this guy right here. And then we go ahead and add down. So, Gerchow, negative 8y minus 8z equals negative 8. And that's what goes right here. Once we have that done, we move on to the next step. Our next step is to eliminate the x value in equation 3. In order to do that, we need to use the system that we just got done making. So we're going to start with that guy. Now again, our top equation and our middle equation is going to stay the same. So we're going to do negative 2 equation 1 plus equation 3 to give us our new equation 3. So those top two equations stay the same. Your bottom equation is the one that's going to be changing. So when I multiply that guy, I get negative 2x minus 6y plus, I lied, minus 4z equals negative 10. And then I'm going to go ahead and write that bottom equation right underneath it. So then, kerchow! Negative 4y minus c equals negative 7. That's what's going to go right here. So the next we want to eliminate the y term in equation 3. So in order to do that, I can actually leave my second equation the same, and then I can add to that negative 2 equation 3 for my new equation 3. So when we do that, top two rows stay the same. I go ahead and replace that third row with the negative 6z equals 6. And then that allows us to move on to the next part of the equation, where we want to make the z coefficient equal 1. So in order to do that, we have to use the second thing we're allowed to do. So we can multiply one of the equations by a non-zero real number. So in order to make that z coefficient to be 1, you have to do negative 1, 6, multiply that by equation 3. That gives you your new equation 3. So we are almost in triangular form, which means the last thing we got to do is make the y coefficient equal to 1. And again, we're going to multiply by a non-zero real number in order to do that. Negative 1/8 equation 2 to give me my new equation 2. This gives us our resulting equation, which shows us that it is in triangular form. Because, if you notice, this creates a triangle. And each of those variables that are in that diagonal all have a coefficient of 1. Then once we have it in triangular form, we can use substitution in order to solve the system. So essentially we take that z value and we plug it into our second equation to find y. And then we take our y value and the z value and plug it into the top equation to find x. Now that you have your x, your y, and your z, you're going to write it as a ordered triple. Yeah, happy cloud. Okay, I know what you're thinking. If every problem takes that one, it's going to take us forever to do our homework. I know. Which brings us to the next one. Write the augmented matrix for the system of linear equations. Here's what you do. Step 1, square brackets. Step 2, vertical dotted line over on this side. Step 3. Now, we're going to write these for guidance, but we don't always necessarily need them, nor should you write them there every single time. So now you're going to write a system, right? You're going to write your coefficients underneath each one of those things. At the top of your columns, you have your variables. You have your equal sign, which is that vertical line, and then you have the constant or the number on the other side. First equation, we write it across. There is no w, so it's a 0. Got a 1 for x, 1 for y, negative 1 for z, 5 over on the other side. Then you go ahead and you have your second equation there. You got your 2, your 3, your 0, -1, and -2. 0 for y because there is no y there. Then you got your last one. This time the 0 goes in the z column because there is no z there. Guess what? This is your augmented matrix. However, for the augmented matrix, it does not need these at the top. There we are. And moving on. Our next example is asking us to determine whether each matrix is in row echelon form. What's row echelon form? Great question. Let's scroll down. On this side, you will notice that you have row echelon form. Zeros are in this bottom corner, ones go down the diagonal, and then you have just numbers all on this side. If it's special, that means that it's reduced row echelon form, which means we still have those ones in the diagonal. We have zeros down here, zeros up here, and numbers on the other side of that vertical dotted line. So as we look at these guys, a couple things we're looking for. First, ones in the diagonal. Ones in diagonal. Second, we want to check for zeros to the bottom left of that diagonal. If that happens, like what has happened here in our first one, bada bing, bada boom, this is at least row echelon form. So the next thing you want to check to see is you want to check and see if this is a number or this is a 0. Since it's a number, then that tells us that this one is row echelon form. The second one, you will notice that we have 2 other zeros here in this column. That makes it a no, not in row echelon form. Ah, shucks. The last one, you'll notice that, hey look, we got ones there. We got zeros here, and we got a 0 up here. So far, so good. See how this row of zeros is at the bottom? Yep, I see it too. Isn't it great? That is allowed and that is okay. Notice over on the second one, the row of zeros was not at the bottom. Not okay. That throws your whole answer off. So this one, since we had a 0 up here too, this means that this one is reduced row echelon form. Ta-da! And that's all we do for that one. So as we move on to the next one, now we're going to use matrices in order to solve this. We have 3 families: ordered meals of hamburgers, represented by HB, french fries, represented by FF, and drinks, represented by DR. The items we ordered and their total bills are shown below. Write and solve a system of equations to determine the cost of each item. Here's the best part about this. It's in a table, which means the highlighted portion is pretty much already a matrix. Which brings us to our first step, write an augmented matrix. Step 2, we're going to go ahead and solve that. When solving this, I want this top one to be a 1. How do I get that to be a 1? Well, I see there's a 1 there down in the bottom row, so can't we just switch that? Great idea. We can switch them. Here's how we write that. We have row 1, switch with row 3, that double arrow means that. And then my resulting matrix will look like this. We just switched row 1 and row 3. And then we can continue on with our mission. Now, at all points in our mission, we always want to continue on with the operation. The operation avoid fractions. My next step is I want that 2 to be a 0. So if we look to see how we can make that 2 be a 0, we can multiply that top row by a -2 and then add it to our second row in order for that to eliminate. Our resulting matrix is going to look like this. Then the next thing we want to do is get this 6 at the bottom there to be a 0. So then we get that resulting matrix. When we do that, -6 row 1 plus row 3 equals row 3. Now, it looks like our operation is about ready to get a little bit more difficult. So we're trying to avoid fractions. I don't want. Oh, but trust me, you really do want to. It's not all it's cracked up to be. So, the next thing that we want to do is we have two options. Option 1, make that -5 be a 1. However, the only way I can see of doing that is possibly, you know, a lot of multiplication. The other option is trying to change this -13 to be a 0. Yet again, still seems like a difficult option. So we're going to roll with trying to make this -5 become a 1. So we can multiply 2 rows by a different number. Let's try this. Miraculously, we get something as simple as 0, 1, -1, and 1. So then next I want this -13 to go ahead and be a 0. So to get that to be a 0, we're going to go ahead and multiply row 2 by 13, add it to the third row, and then that guy will be a 0. So when we do that, we get 0, 0, -20, -40. Now, last but not least, we want that -20 to be a 1. So, we have been doing Operation Avoid Fractions. However, we can finally use fractions for our benefit. So now we have our matrix. Our matrix is in row echelon form. It is also, if we were to write the equations would be in triangular form. So your next thing is you could write out those equations and then solve them. You can also keep going to get it in reduced row echelon form. The next one we're going to do, reduced row echelon form, but right now we're going to go ahead and write out our equations in order to solve them. So we have this equation written out. We know what our d value is. We're going to substitute and then solve. Whenever we substitute and solve, we get that the drinks are $2, French fries are $3, and hamburgers are $5. Our next example, we want to go ahead and solve the systems of equations, just like in the previous one. Step 1, write augmented matrix. Once you have that written in an augmented matrix, just like before, I'm going to make sure we have a 1 in that upper corner. We do. Happy day. Which means the next thing we want to try to do is we want to get that to be a 0, but that was the wrong color. Let's try again. There we go. We want that guy to be a 0. So then whenever we do that, we can take row 1 and we can add that to row 2 to give us our new row 2. Rows 1 and rows 3 stays the same. Row 2 becomes 0, 1, 0, 5. So once we have that, the next thing is we're going to keep moving down that first column. And now we want this 2 to also be a 0. Then we can do -2 row 1 plus row 3, because it's our new row 3. We end up with that guy there. Our next step that we want to make sure is we want to make sure that that's a 1. Cool. It is. How nice. And our next step is we want to make sure that this guy's a 0. Not a 0 net yet, but we can get it there. We can take our row 2 and add our row 3 together, and that'll give us our new row 3. Which leaves us with the resulting matrix, where we have 1s in the diagonal, we have 0s down here, and then the next thing we want to shoot for is we're going to shoot for getting these to be 0s as well. We're already well on our way, but we have 2 more steps, and then our matrix will be in reduced row echelon form. So the first thing we want to do in order to get 0s in that top spot is we want to get this to be a 0. That guy there to be a 0. Because we already have a 0 right here. So, to get that top one to be a 0, row 1 plus row 2 gives me my new row 1. Now when we do that, notice our second and third rows stay the same. And then our next step is we also want that 1 to become a 0. In order to do that, we're going to take negative row 3 plus row 1, give us our new row 1, giving us that resulting matrix there. Now, benefits of reduced row echelon form. Your last column is your answer. So you just take that and you write it as an order triple and you're done. You don't have to do any additional solving. Next example, just like the last one, step 1, go ahead and put it in an augmented matrix. Once you have an augmented matrix, then you want to try to get a 1 in that top corner. We have 2 different options that we can do in order to get the 1 up there. We have either row 2 or row 3. Doesn't matter which one you pick. I'm going to choose to switch row 1 and row 2 so that row 3 stays the same. And then row 1 and row 2 switch. After you have that done, then next you want to get that 2 to go ahead and be a 0. When you go ahead and eliminate that, so negative 2 row 1 plus row 2, that gives you 0, 1, 3, negative 9 there. And then our next step is we want this 1 to also be a 0. I'm going to do negative row 1 plus row 3 to give me my new row 3, which means my first row and second row are going to stay the same. Then my third row becomes 0, 1, 3, 3. Moving right along, just like we did before, we want this 1 to be a 0. In order to get that to be a 0, we're going to take negative row 2 and add row 3 to that to give me my new row 3. Now, when this happens, notice how we have all zeros on this side. Then there's a 12 on the other side. So even before we fill in that top part, what that bottom row is saying is that 0 equals 12, which is false, which means that this has no solution. Now, just on another note, if you get a whole row of zeros on the bottom, this means that it would be all solutions or infinite solutions. The last example that's in your notes there is something that's a little bit of a bonus example for you. If you check out the PDF, you'll see how to solve that one there. But otherwise, you can go ahead and get started on your 6-1 homework. Yay!